Assalamu alaikum wa rahmatullahi wa barakatuh. Students, how are you all? I hope all of you will be fine and enjoying good health. Please take care of yourself because these 2 weeks they are very critical and the number of patients which are suffering from coronavirus they are increasing day by day. So take care, try to be hygienic and pray 5 times a day and pray to Allah Almighty that may He help us in this time of distress. Ameen. My name is Humble Mohammad and I am going to teach you physics. This is lecture number 3 and you know that we started chapter number 7 which is properties of matter. So let's start. The topic is pressure in solids, atmospheric pressure and barometer. These are the topics you are going to review in this video and I will try my best to explain them as much as possible because in these video lectures we try our best so that the students can have a feeling of physical presence. So the topic you are going to cover are pressure in solids, atmospheric pressure and barometer. So please pay attention. Okay, the next one is definition of pressure in solids. First of all, we are going to define, as you know very well in physics, we always define a physical quantity properly. Previously in this chapter, you discussed about kinetic molecular model and its postulates, and after that I discussed with you solids, liquids, gases and plasma, all the states, and I told you about the structures of these states. And at the end, we discussed density in that video. Now, after that, in the next pages, you will find these three topics: pressure in solids, and then barometer and atmospheric pressure. So I recommend that after watching this video or while watching this video, you can open your book and you can also go through these pages. So let's define pressure. Defined as the force per unit area. um, any area you can take and you are going to apply force on that area. Say for example that you have a page, a paper, a copy page with you, and you are applying or you are applying your thumb on that page. That contact area is the surface on which you are applying pressure. So when you are going to divide force applied by you and with the area, contact area, then you will get pressure. The next point is force is measured in newtons, area is measured in square meters. You know very well these are SI units. And the third point is pressure is measured in pascals, whereas 1 pascal is equivalent to 1 newton per meter square. What does it mean? It means that always after defining a physical quantity, we always define its SI unit. So this 1 newton over meter square, Pascal was the scientist who did a lot of research in this regard. So he gave the name 1 pascal to 1 newton per meter square. Okay, let's talk about now examples of pressure in daily life. Pressing a thumb pin into a surface. You know very well you have drawing pins with you. Whenever you use a drawing board and whenever you put some type of display on a notice board, you can use thumb pin. That is the best example. Why have you ever thought that why they have made it so pointly sharp? Why? Because it is having very less contact area, and according to the equation P is equal to F over A, less contact area will give you more pressure. So that's why thumb pins can be used by applying a little force, but the pressure will be more due to less area. The next example is surgical instruments used in operation theater. Those surgical instruments, their areas are very very less and they are very very sharply pointed. Why? Because by using very very less force, they can go into the skin of the patient. So that's why the pressure concept of pressure is also used there. And the third point is in some situations lower pressure is recommended, as in the case of wide tires, school bags, straps, because all of these things they are made with more contact area. As you know, the tires are made wide so that they can have less pressure in case of puncture. And after that, school bag straps, why are they made with more contact area? So that whenever the students they wear the bag with that straps, they will feel less pressure. Now by increasing the area, we are having less pressure. Why? Because P is equal to F over A. Again, the same situation is there. You know very well, when the quantity in the denominator, when it is increasing, the quantity on the left hand side, that always decreases. And same is the case with suitcase handles. Okay, the next topic is atmospheric pressure and barometer. What is atmospheric pressure? The pressure is exerted by the weight of the atmosphere. You know very well, on our planet, that planet has been descended upon by uh, a very big envelope of air, in which a lot of gases are there. So the pressure applied by the weight of that mixture, air is a mixture, that pressure is called atmospheric pressure, or you can also say that the pressure is rated by that atmosphere. So at sea level, this pressure has a mean value of 1,01,325 pascals, roughly 14.695 pounds per square inch. So it's a very high pressure, but because of uh, the body is made by Allah Almighty, He has um, balanced our inside pressure with the outside pressure. That's why we can handle this pressure. Otherwise, it is very difficult to handle this pressure. And the third point is atmospheric pressure may be measured using a barometer. You know very well, always we are interested in measuring a physical quantity, whether it is theoretical or practical. Um, Now let's discuss what is barometer. Barometer, the instrument used to measure atmospheric pressure, is called barometer. Mercury is used as a liquid in it because mercury has some type of characteristics that it can be used in making barometer. First of all, it is liquid at room temperature, and secondly, it is having linear expansion, means that for same increase in temperature, its increment is same. So as you can see in the figures, that when atmospheric pressure it is applied on the mercury in the trough, the mercury in the tube it increases, mercury level in the tube it is increasing, and at sea level it was measured to be 760 millimeters. So here the pressure can be measured in the shape of length of the column of mercury. So 760 millimeter means that at sea level, at normal atmospheric pressure, its length is 760 millimeters. So now whenever it is brought to the higher surfaces, like when say for example you are taking it to Murray, so Murray is around about 4 to 5,000 feet higher above the sea level. So that's why the pressure is less now, because most of the air you have left behind. So as you will increase the height from the sea level, you will see that this level will drop. So it means that the pressure is decreasing, and whenever this level is increasing, this the level of this mercury column, whenever it is increasing, it means that it is showing that the pressure is being increased. In Karachi it will be different, in Lahore it will be different, and in northern areas where the height is very much higher as compared to sea level, as compared to the sea level, you will see that the pressure will decrease due to less atmospheric pressure. In the second diagram, as you can see, the more pressure there is, the higher the mercury rises in the tube. The air pushes down on mercury. So with these figures, it is very clear that this simple instrument can help you in determining the atmospheric pressure anywhere, whenever you want. So I hope that you have enjoyed this video, and you have came across pressure in solids, and then atmospheric pressure, and then barometer. So I recommend that read these topics from that book, and if you have some type of query, you can ask in the group, and take care. Allah Hafiz.